Write down an expression in terms of n for the nth multiple of 5. Hence or otherwise, prove that the sum of two consecutive multiples of 5 is always an odd number. Prove that the product of two consecutive multiples of 5 is always an even number. So for the first one, prove that the sum of two consecutive multiples of 5 is always an odd number. Before that, we need to do the nth multiple of 5, obviously is 5n. And now we have to do the sum of two consecutive multiples of 5. So the two consecutive multiples of 5 would be 5n, 5 times n plus 1. They would be consecutive multiples. Now n could be odd or even. So here, if n is odd, then n plus 1 is even, and if n is even, then n plus 1 is odd. So it's vice versa, and whether n is even or odd, it doesn't really matter in this case, because you are taking the next one, n plus 1, which would be even or odd depending on what n is. The other thing is 5n. You see, if n was even, so 5 times 2 you'd have 10, which is even, and 5 times 3, which is odd, you'd have 15. So which is an odd number, and then odd times even is even, and odd times odd is odd. So then, bearing that in mind, so we have to add the sum of two consecutive multiples of 5. So there would be, so sum of two would be 5n plus 5 times n plus 1, and that would be 5n plus 5n plus 5. That is 10n plus 5. Now, is 10n plus 5 odd or even? Now 10n is an even number, always. 10n is always an even number. It ends in a 0. It's an even number. So 10n plus 5 is an odd number, and even plus odd is odd. Therefore, sum of two consecutive multiples of 5 is always an odd number. Of 5 is always So we've got that proof. The second one is proof that the product of two consecutive multiples of 5 is always an even number. So I need to erase this bit out, otherwise I can't write. I didn't use the next slide. So if we'd still have the consecutive multiples of 5 as that. So I need to keep that. And the same explanation would hold, that if n is even, then n plus 1 is odd, and if n is odd, then n plus 1 would be even. So consecutive multiples of 5 are 5n and 5n plus 1. We're doing 2 now. So the product of two consecutive multiples of 5 is always an even number. So the product of two consecutive multiples of 5 would be of 5 would be 5n multiplied by 5 times n plus 1, and that equals 5n plus 5n, not plus, multiplied by 5n plus 5, and that would equal 5n times 5n is 25 n square plus 25n. So we can write this as, if I take 25 outside the bracket, 25n times n plus 1. So once again, if you notice, what is happening is, so this 25 is odd. N could be odd or even. If n is odd, then n plus 1 is even. So odd times even is even. So whether n is odd or even, it doesn't matter, because if n is odd, so we can pick any example like 3 times 9 times 2. So you'd have 27 times 2 is 54, or you could multiply it by 8. So whenever you multiply it with any even number, it will be even. So 27 times 8, or you can say anyone say 1 times 5 times 6, it's always 30, 4 is 20. So it will be even, odd times odd times even. So if you had n is even, you see n plus 1 would be odd, and you would end up getting the same result as an even and an even number. So it doesn't really matter whether n is odd. So an odd times odd is even. So since odd multiplied by even multiplied by odd or is even, therefore this would always be an even number. So that's our second proof.